Let's start by looking at the review question from the last episode, asking us to identify the scenario where an AI or ML solution would provide the most value. The correct answer is D, because detecting fraudulent transactions in real time is an ideal application for AI or ML, given we need to process and analyze vast amounts of data quickly, and it requires identifying complex, ever-changing, and often subtle patterns that may indicate fraud. The other options are all straightforward tasks which don't really require the adaptive or learning capabilities of AI. So let's get on with business today. Today we are going to be covering the objective, select the appropriate ML techniques for specific use cases. For example, regression, classification, and clustering. Let's start with regression. This technique is used to predict continuous numerical values. I'll let you in on a secret. That's just a fancy way of saying you want to predict a number. Do you remember back in episode 1, I talked about predicting house prices based on location, size, and number of bedrooms? Well, that is a regression problem as we're predicting a number, the price of the house. Next, we have classification. This technique is used to categorize data into predefined classes or labels. Now cast your minds back to episode 4, where we talked about supervised learning, and I gave the example of training a model to predict the type of flower. You remember that with my great flower illustrations on the whiteboard here? Yeah, you remember that. So that was actually a classification problem, as we were trying to identify the type of flower based on its characteristics and assign it a label, which is essentially a categorization. Now you might have noticed that regression and classification tend themselves towards using labeled data and a supervised learning approach. So we say that regression and classification are largely supervised learning techniques. But what about unlabeled data and unsupervised learning? Well, don't worry, we haven't forgotten about those. We have something called clustering. This technique is used to group similar data points together without predefined labels. And this is super useful when you want to discover patterns or groupings in your data. For example, maybe segmenting customers based on purchasing behavior for targeted marketing, or grouping news articles by topic without predefined categories. We say that clustering is an unsupervised learning technique. It doesn't require labeled data, as the goal is to discover inherent groupings in the data without predefined categories. Now, just a pro tip for all of you. Sometimes you might need to combine the techniques, and that's completely fine. For instance, you might use clustering to group customers and then use classification to predict which group a new customer belongs to. All right, let's do a review question. A social media platform wants to automatically categorize user posts into predefined topics such as sports, politics, entertainment, etc. They have a large data set of posts that have already been labeled with these topics. Which combination of learning approach and machine learning technique would be most appropriate for this task? Ooh, I'm bringing in some stuff from a previous episode as well. Would it be A, supervised learning with regression? B, unsupervised learning with clustering? C, supervised learning with classification? Or D, unsupervised learning with classification? We'll review this in the next episode. Catch you then.